Hey folks, so in our last conversation we started out the lesson by discussing different types of three-dimensional shapes and remembering what their names are and how to identify them based on certain visual characteristics, things that we can see about them. That will help us to solve problems involving them, because it's really important before you solve a problem involving any of these three-dimensional figures that you know what figure it is that you're looking at, because that will help you to find the right formula to calculate its volume. Okay, so in the last video we went on to talk about prisms and cylinders and how to calculate their volumes by looking at the area of the base and then multiplying that by the height of the particular object. So for instance here I have a cylinder with a round base, so in order to calculate the volume of this particular object I would find the area of its base and then multiply by big H, the height of the object itself. So now I think we're ready to continue talking about three-dimensional objects from the perspective of pyramids and cones. And what I'm hoping to do through this demonstration is to show you the relationship between prisms and their pyramid counterparts and cones and their cylinder counterparts. And I'm going to get into that. So people, over the course of time maybe fiddled around with these objects and tried to develop mathematical relationships between their sizes. And that's because, if you have a quick formula, then it'll allow you to do calculations really easily, even in complicated situations. So what I have here, the two objects that I'm comparing, this prism, it's a rectangular prism, happens to be a cube, but, any rectangular prism. And I'm looking at the pyramid that it most closely resembles. Okay, so I'm going to call it the analogous pyramid. And I'm calling it that because they have to have the same height. So if I compare these two height-wise, they're the same height. And if I compare their bases, the bases are of the same length and width. Okay, same size. What I'm going to do is I have some sugar here. And I'm going to fill up my pyramid with that sugar, and I'm going to make sure that you can't see me doing this right now. I'm going to show you in a minute. Filling up the sugar, this pyramid, with that sugar so that it's at the top. And now what I'm going to do is I'm going to dump this into my cube. Okay, so I'm going to actually bring my little sugar container right over here so I don't make a giant mess everywhere. And I'm going to see if I can show you this, putting it right in. There we go, there I go, there I go. Okay, and now I'm going to kind of let that settle. There you go. I'm going to put this down for a second while I fill up my other pyramid, the same pyramid, one more time, because it's not completely full. So I know at least one pyramid will fit into its analogous prism so far. Let's do this again. Here we go. Boom. So I'm not there yet. Okay, so I know at least two pyramids will fit into their analogous prism. Let's see how well this is going to work out for me. Let's give this a whirl. Let's fill it up with some sugar. Okay. And so, oops, filling that up really carefully. And smoothing it out. Ooh, sugar. Literally. Smoothing it out. I can see that if I had done this super well, it would turn out that exactly one more, so 3 pyramids can fill up the analogous prism, which is really cool. So that allows us to develop an understanding of where the formula for pyramids come from, and sets us up with a nice little rule that can help us perform these volume calculations. So let's take a look at that. Alright, so to visualize that again, I took 3 pyramids that have the same height and base as their prism counterparts. And I was able to take 3 of them, fill them with sugar, and that completely filled the volume of the prism exactly. So that sets us up for a special rule. And here's that rule. Okay, so the volume of a pyramid is going to be 1/3 the volume of a prism with the same base and height. They repeated this experiment with several different prisms and their pyramid counterparts, and they found that the volume of the prism was always going to be the area of the base times the height of the pyramid itself. So to put that in variable form, the V of the pyramid is going to be big B, so that's the volume or the area of the base. So in this example here I have a triangular prism, okay, so its base is a triangle, times the height of it, right? So in this particular pyramid right here, if I wanted to find its volume, I would say, well, the area of its triangular base times its height right up to the center. But it needs to be a vertical line right down into the middle of that pyramid. And then I'm going to take those and divide them by 3 to get 1/3 of the total volume of the prism that it's most similar to. So I don't know whether people experimented with prisms and pyramid relationships first, or whether they looked at cylinder and cone relationships first. It doesn't really matter, but the point is that if they looked at the relationship between one set, they probably wanted to explore that further to see if other similar relationships existed. So I'm going to do a little demo to see what they might have looked at. So here I've got a cylinder and I've got a cone, and notice they have the same base and the same height. Hard to tell here, but yeah, they do. Just, yeah, trust me. So what I'm going to do is I'm going to see how many of the cones will fit into this cylinder. Now remember, it's an experiment. It's not going to be exact, but it'll give us a good idea. So here we are. I'm going to fill this sugar up, this cone up with sugar. And I take my little cylinder, boom. Okay, looks like it's, it's about 1/3 here. Interesting. Take another one, fill it up. Be careful because there's a lid on here. And pour it in. Boom. Let that settle. Okay, so 2, not quite full. And filling this up a 3rd time. Boom. Trying not to get everything everywhere. Okay, so I would imagine that if I shook this a couple times, I would see that the volume of sugar would be based on 3 cones into the cylinder would be, exactly 3. So exactly 3 of the cones would fit into my cylinder with the same base and the same height. Not really surprising, I think. I think probably most of you would have guessed that, if maybe you knew it already. But there it is for you. And so again, remember, this is an experiment, not hugely accurate, but time and time again, when people explored the relationship, they found that that existed. So let's look at some visuals to help recap this. Okay, so here I have cone and cylinder with same height and same base. By dumping 3 of the cone volumes into the cylinder, I completely fill it. So what that tells me is that a cone has 1/3 the volume of a cylinder. Okay, here's a nice handy dandy rule. So for instance, if I have this cone that would nicely fit inside the cylinder, so it has the same height and base, then its volume is going to be 1/3 the volume of that cylinder. So the volume of any prism is going to be the area of the base times the height. So the volume of the cone is going to be, the area of the base times the height of the object, and then I'm going to divide by 3 because the volume I know of that cone is going to be 1/3 that of the same cylinder. So, but remember that the volume of a cone has a base that's a circle. Okay, that cone has a circular base. And so what is the formula for a circular base? Well, it's pi r squared. So that's why I have this little bit in right here, because that's, that's how I calculate the area of that circular base. Okay, and then I'm going to multiply that by the height, but that's not, I need to be careful about what height I'm talking about. So let's just make sure we understand that. The height I'm referring to, keep getting that wrong. There we go, is the height of the cylinder itself. Okay, has nothing to do with that base. All right, so there's a discussion, a nice demo showing you the relationship between cones and cylinders and prisms and pyramids. The next video will show you some calculations to help support some of your actual work and problem solving that involves calculating volume of pyramids and cones.